Hi guys, today we'll be talking about structured query language. This stands for SQL. That is the next part of our class. Now that we are done with conceptual data model and logical design, we're actually ready to work on the internal data model, which is table creations, retrieving data from existing tables, and looking into how data is organized on the level of the database. This is more fun part of our class, so hopefully you guys like it a little more compared to the other parts that had to deal with logical design and conceptual data model, advanced entity relationship diagrams and entity relationship diagrams. So let's start. Let me clear the screen a little bit here. All right. I'm going to minimize that, and we're going to go with the slideshow. All right, so today we will be talking about two parts in SQL language. First part, we will deal with data definition language, when we'll be creating tables and different objects. And the second part, we will be dealing with DML, data manipulation language. In other words, creating data in the tables and retrieving data from the tables. And at the end of this lecture, we're gonna talk about queries, how to create queries, what are the parts of the queries, and we're gonna be able to to write simple queries to retrieve data from one table in one condition and using multiple conditions. And next lecture, we will be dealing with advanced SQL, where we will be retrieving data from multiple tables. So let's start, shall we? My favorite diagram is here. So as you guys can see, we started from external data model where we talked about business rules, how they're defined. Then we created entity relationship diagrams and conceptual data models. That's what we did during a couple of first classes in this course. And then we moved to logical model, which we did the class before exam. So as part of logical data model, some of you did database normalization, which is last question on our homework too. It's extra credit, but some of you also learned about normalization. Normalization is bringing data into the third normal form. Now, today we will talk about how to create internal data models, meaning tables, columns, and how to create database-specific objects. So we're currently working on internal data model. So when we deal with internal data model, the most common concept here is data retrieval. Data retrieval is used SQL. SQL stands for Structured Query Language, and often pronounced as SQL. That's how I call it. It is a standard for all relational databases. So SQL may be a little different when you go from the platform to platform, when you go from different databases. So for example, your SQL for SQLi database might not look exactly the same as your SQL for SQL Server or Oracle, but people who learn basics of SQL language, even with this class, you should be able to extend your knowledge further. When we're during this class, we are dealing with relational database management system. Relational database management system relies on relation. We talked about relation. We all know what relation is from the previous couple of classes. Relation is a two-dimensional structure of data. It's similar to table, but it has certain criteria for table to specify as relations. So relational databases have relations in their base and foreign and primary key constraints that support those relations. And that has to do with referential integrity constraints. For those of you who already went through the lecture of logical design, you know that referential integrity constraint in the diagram is represented with arrows pointing from foreign key to primary key. We also know that foreign key always sits on many sides of relationship when we're converting interrelation diagram to logical design, we always have to put foreign key on the many side of relationship, and that will be representation of referential integrity constraint. There's a little video for you guys, 90 seconds sequel, so you can watch it on your own. You can pause the video and watch it. I think it's pretty fun. So watch that and come back for the video, and we'll continue with the class. Right, welcome back. So here's a little history. Hopefully it was fun. I really like those short videos. I start incorporating them in class structure lately. Here's a short history of SQL. Not so important, but I just put it there for you guys so you would know where it came from. And obviously, I mean, it all started from Cod, who also developed relational data model. So the purpose of SQL, why do we need this SQL language to get data from the database? The main purpose is standardization. So when you have multiple relational databases, you need some standards on how to get data from the one database and how to be able to use the same data retrieval processes when you deal with multiple databases. So say, for example, a company decided to convert from MySQL database to SQL Server database. While your physical structure of the database is going to be different, all the data objects, including queries, stored procedures, and everything you do with the database, is going to stay pretty much the same. So the main purpose of introducing SQL language was to be able to standardize the data retrieval processes from the database. Multiple benefits of SQL, productivity, reduced costs. Also, I'm not going to spend a lot of time here, but the main idea is we needed some standard concept that allows us to use same data retrieval routines or similar data retrieval routines across multiple databases. So SQL requires environment. So what is an environment? Environment is a place where you do all your work. So when we talk about SQL environment, that includes catalog. Catalog is the largest container that sits on a relational database. So one database can have multiple catalogs, and then it goes down from catalog to schema. Schema has one catalog can have multiple schemas. Schema is a structure that holds related table together. So, for example, if we're dealing with the database that has a lot of information, a lot of financial information for the company, we can group order processing in one schema. We can group customers or client processing in another schema. In this way, your one schema that has order processing will probably include invoices, list of product price, and so forth tables. The schema that contains customers' information is going to include all the customer relation information, potentially some marketing leads, customer table, discount table, anything related to a specific customer. Within the schema, we have multiple tables together. And when we talk about tables hold information specific to a certain object. So, for example, if we're talking about a customer, one table can hold customer information, including first name, last name, and all the personal information. Another table can hold for example, customer financial information. That's where we store customer credit cards, different different methods of payments and stuff like this. So table holds information specific to certain objects. So there's customer table and there's customer financial data table. There's three different types of languages that are that are part of SQL. In this class, we are only going to cover first two. So when it comes to SQL, we have a data definition language that has to deal with creating data objects. So every time we need to create data objects, we use data definition language. So we define our objects. When we manipulate with data, or when we insert data in the tables, delete data from tables, retrieve data from tables, we use data manipulation language. So we are going to cover those two in this class. There is also data control language that controls various administrative tasks required for the database. So for example, creating users, dropping users, giving users permission to certain data objects. So this is a little more advanced concept that is not part of this class, but for those of you who decide to have a career in the databases, you will definitely spend more time dealing with the low-level concepts like data control language. Right. So here's a representation of what we just talked in the diagram. We have catalog, and catalog contains multiple schemas, and the schema can contain multiple tables, and table has many rows. So that's pretty much the very basic structure of every relational database. Important. So when it comes to the databases, databases are usually used for software development. So when it comes to the development, every software or application development environment usually consists of multiple environments. So there's one environment where we do all the work. So we create new objects, we test those objects. Every time we need to add something, we need to be able to have some kind of a playground. So that is a dev environment listed on the left side. And dev environment, obviously, for application development has the same dev environment for the databases, and we call it dev catalog. So dev catalog has a development environment catalog, so pretty much a playground for engineers to work on data objects. There's also production environment. So when it comes to production environment, this is a real live data. So that is something that our users are using. That is something that we have underneath our application. So that is a catalog that is our final version of data. So after we test something in the dev environment, we move to production environment, and that's where we have the real user data. So again, similar to software development or application development, databases also have different environments. So when we're talking about environments for the databases, those would be catalogs, and it's going to be a development catalog and production catalog. And production will have real-time data, and development is a playground for the engineers to develop data objects. All right. Within that, the production environment is a live version of data, yes. And dev is a test version of data. Right. So within SQL, there are different data types, and we look at something similar to that a couple of lectures ago. So there's different data types, and there's much more, guys, than that in the real world. But for the structure of this class, that's the only thing you need. So that should be enough for you guys to create your tables for the final project, and that should give you some idea on how data is structured in the databases you will be working in this class. So in this class, you'll be working with two databases. One database you will use called Space, you will use for your homework 3 and 4, and Chinook database, well-known database in the industry, we will use it to practice our queries during the classes, and we are also going to use Chinook when we will be creating queries for our SQL exam. So when it comes to data types, there is numeric data type can be integer and decimal, and clearly integer is a number without decimal point, decimal is a number with decimal point. Character string can be character, variable character, character is just one character, variable character can have like multiple characters. So for example, in this case, example is hello. Hello has hello is 5 character string. There is Boolean. So Boolean means it can have only two values, true or false. So when the value is, there's no other options. Boolean data type is very good for defining, for example, if you remember from our homework 1, we had in question 5, we had to add an attribute is removed. So that would be an example of Boolean data type. So for example, it can be true or false. If it's true, it means that the posting is removed. If it's false, it means that posting is not removed. And in addition to those 4 data types, actually 5 data types, there's also date and time. Date and time is great to use when you need to record a specific date of time of something happening. So for example, invoice date, employee start date, sometimes you need to record timestamp too, sometimes you don't. I would say probably for the purpose of this course, you don't need to worry about date time, you just need to worry about the date. Okay, and here is a difference on how date time attributes look. Right. So let's start from DDL. So when it comes to DDL, there's 3 main create statements that we will deal in SQL. So in this class, we will only be creating tables, but just like we talked before, there is also schema. Schema holds multiple tables, so you can also create a schema, and you can also create a view. View is also outside of scope of this class. However, yeah, I have a couple of examples that I can show you guys later. So for those of you who are interested in advancing your SQL knowledge, I mean, you guys can play with views too. So data definition language, DDL defines the structure of the database. So you can do, with DDL, you can create tables, you can modify tables, or you can delete tables. So you can also do the same with schemas. So let's start. This material is going to be covered in details by you guys individually. When you'll be working on a team project, we will not be creating any tables during class. I will record a very simple video on how to create a table. There's multiple ways to create a table, but in this class, during actual class time, we are going to only concentrate on creating SQL statements. Okay, so here are basic steps in creating a table. This will come very handy for your team project. So when we need to create a table, we first need to identify the data types and attributes. So clearly we need to look at our logical design, look what kind of attributes we are going to have for a certain table. And some people do that during ERD, others do it during table creation. But I mean, bottom line, you need to start from identifying data types and attributes. And attributes are going to be columns in the database. So you also need to identify columns that can be null. This is very important because for those columns that cannot be null, you will need to set up certain constraints. You'll also need to identify columns that can be unique. For example, those can be completely different from your primary keys. So for example, you can have a rule when customer email must be unique because that is something that you will be using to identify customers in addition to primary key. So that means you need to identify unique constraints. Obviously, you need to identify primary and foreign key relationships, which is very important. Um, that should be also done by logical design. You'll also need to determine the default values for some columns. So some columns might not, if you don't have any value for any data to insert for certain columns, you will need to set defaults. So those defaults will be used when you don't specify your data on the insert. So um, you also need to identify additional constraints on the column. So those would be domain constraint specifications. We've done it a couple of weeks ago when we worked on logical design. So it's also part of table creation. And later on, after a table is used for a certain amount of time, you might potentially need to create indexes. And those indexes will define how the data is going to be retrieved from the database. Here's an example of create table format. So it's just a statement that you guys will, all of you will be using it in your team projects. So create table, and then you need to give it some table name, and you identify the list of columns underneath. Each column must have data types and constraints, if any. And then after you're done with columns, you have the list of constraints. And first type of constraint is going to be your primary key constraint, which every table will have. There's also foreign key constraint. If your table holds some foreign keys, so in other words, if your table is on many side of relationship in ERD, that means that you need to create a foreign key and you need to specify foreign key constraint. There is a way to do it in SQLite through UI. There is a way to do it through SQL statements. We're going to look at both. And underneath primary and foreign key, you specify the list of additional constraints if you have any. In this case, I have an example of check constraint. So you need to check a certain condition and then you set a certain value. So for example, if user type, say, MIS 380, you might have a constraint to insert database foundation system class there instead of actual abbreviation of the class. So this is an example of check constraint. Here's a table. Example of the table employee with different data types, different constraints. So that's an actual example of the employee table from our SQLite database. So constraints. When we talk about constraints, there's different types of constraints. The most used constraints are not null constraints. So those constraints are applied to the fields that are that cannot be null. So for example, if you have an order table and you're inserting order information, say for example, your order number cannot be null. So your order number must have a value. So that's an example of not null constraint. We talked about unique constraint. For example, email can have a unique constraint. So those, both of those, not null and unique, those are in addition to primary key. Primary key is unique and not null by default. There's also a default constraint. Default constraint is a value that you want to use if data is not provided. So, for example, if you have, say, employee table and you want to insert in an event, if you want to insert employee table data, you, for example, might not have a department information available yet, so you can by default assign all employees into general department, and then there might be a rule that runs on the database and checks for general department, and then moves employees around different department as needed. There's also check constraint. We talked about check constraint before. Here's another example of check constraint. So for example, you need to check for price being less than 10. So if price need to be greater than 10. If price is less than 10, your database is going to throw there. So there's very important thing. So there's a difference between column and table constraints. Column constraints are shown above, and table constraints we talked about before. So those are specific table constraint. So we're going to talk about column constraints in a little bit. Okay. So here's an example of constraints. You have an employee table here with actually seven different columns, and here's a list of constraints. So, for example, first name is should not be null. Gender must fall in those two categories. So, department must be default is general, and email must be unique. So, unique, not null, check, and default are constraints. Okay. Um, Another example of constraints here, so just put it here for you guys to use on your team project if you need to do it. Referential integrity constraints. Remember, I promised you that we're gonna get to this topic when we'll be working on database creation. So here it is. When we are creating foreign keys, we need to understand what are we going to do exactly if something happens on the primary key of this constraint. So in this case, foreign key is order ID and references order table order ID. So there's a couple of rules. On delete, we want to restrict. What does it mean? It means that if there is a data in order detail table, we cannot delete order ID. So say, for example, someone is trying to delete records from the order table. So if we have the constraint set on delete restrict, we will not be able to delete delete record from the order table if order detail table has some data. On update cascade means that we will be able to update primary key data in the table. But if you have a foreign key dependency or records in order detail table that are on many sides of relationship, we will need to update those records too. So again, example on how foreign key constraints are set here. Okay, let's move on to controls. This is something that we already done before. So this is an example of referential integrity constraints that make sure that foreign key values on a table must match primary key or it can be null. So for example, in this case, we have a customer table which has a primary key customer ID, and customer ID is a foreign key in order table. So what restricting in this case means, restricting constraint means that we um, cannot delete primary records if we have values in foreign records. When we update values in primary records, so for example, if we run an update and we set customer to 99 where customer ID is 3, we also need to update all the records that have 3 in customer ID columns in order table. All right, and when we insert data in order table, we need to make sure that customer exists for this order. So for example, we cannot insert order for non-existing customer. It means that we need a customer ID, and this customer ID should be part of customer table. Okay, that's very important for your team project. A lot of you guys have issues inserting something that doesn't have a set of keys in primary key tables. So a lot of issues comes from there. But again, If you see violation of constraint, you should be able to go and make sure that there is a date and your primary key table exists. All right, so talked about that, referential integrity, ensuring referential integrity constraint through updates. So we have customer and order. Order is on many side, customer is on one side. So in this case, just like we talked before, we have a foreign key in many side of relationship, and every time we do something with a primary key, we need to make sure that those actions are not prohibited on the foreign key side. So, for example, if we have a constraint on foreign key cascade update, so every time we update a customer, we must update order table too, and so forth for set to null and set defaults. All right, so that was creating tables. Let's look at the modifying table. So sometimes we need to modify existing tables. So maybe we need to rename the column, or we need to add an additional column. Sometimes we need to drop a column. Sometimes we need to add a foreign key constraint. So all of those modifications of the table are done through alter table statements. So alter table statement looks like this. So we have to write down alter tables, and we need to give it alter table name, and then we include our further action. So the action can be anything we want to do. So for example, we can add foreign key, we can drop column, we can add columns. So anything we want to do in the alter table can be part of this second attribute. There are a couple of examples in our SQL practice for today. I'm going to show you guys how to do it, but again, majority of this work you will be doing during your team project. All right, so we can also delete tables. That's very simple. So for delete table, we use drop table command, and we give it a table name. Well, please make sure that you really need to drop the table before you execute this command. If you execute this command, if you drop a table, so chances are this table might not be recoverable if you drop it. Okay, so that was the extent of DDL that we covered during this class. Now we're going to move to data manipulation language, or DML. So with DML, we are going to cover two types of statements. We're going to talk about how to add data in the table. We're going to talk about how to update data in the table. But majority of the time during this class, we're going to spend on learning how to retrieve data from the table. So this is an example on how to add data into the table. There's two ways on adding the data. So if you need to insert all values in the table, so for example, if your table has three columns, you can type insert into table names, and you just specify a list of those columns, and you don't need column values. You don't need to specify the name of the columns. Sometimes we need to insert only certain values. So because some values can have a default some columns can have a default value. So we don't need to specify those columns, and if we don't have this value available. So here's an example. Number two is an example of the statement where you need to only insert a certain data into this table. And number three is a very specific case. That's when you want to get everything from table one and insert it in table two. When it comes handy. Sometimes people create one table, and they don't want this table anymore, so they need to rename it. Renaming table is somewhat tricky in SQLite, so the easiest way is to get all the data from the old table and put it in a new table. So that would be insert into table one. That's where you need to select everything from a second table. You can also delete data from table. Again, like comes handy when you need to get rid of some certain rows in the table. You can delete the entire row. Then you can delete everything from a table with delete from, and it's going to just keep your table, but it will have no data. And or you can delete certain rows. So when you need to delete certain rows, you delete them based on a certain criteria. So in this case, it's going to be delete from, and you specify criteria under the where clause. We're gonna talk more about where clause in a little bit. So you would know how to build those where clauses. All right, so how do we update data in a table? So this um, becomes handy when you need to change some data that you already have in a table. So there is a way to, similar to delete, there is also two ways to update the data. So you can update all the table data. So for example, you need, say there is a situation when you need to set, you have a customer table and customer discount table. And say, for example, you want to set customer discount for everyone for 10%. So say, for example, you have some kind of sale. So in this case, you execute a first statement where you need to update all the rows, and you run the update, and this update will set a discount table to a new value of a table. You can modify when you need to modify certain rows. So, for example, back to this example, say you want to give discount of 15% to your special customers who are signed up for your newsletter. And this discount is going to be 15%. So in this case, you need to modify only some rows in a table, not all of them. The way you modify it, you specify a condition in where clause. And in where clause, you can say, for example, when is Boolean is signed up for newsletter is equal to true. And that's the way you will be able to update only certain rows in the table. Okay, so that concludes DML part that has to do with the data inserts and updates. So let's start from SQL, from select statements. This is usually a favorite part of students' class here. So we're gonna work on first part of a select statement, and that's a pretty small, easy statement. So consists of three different parts. So select, where we list columns or expressions or anything that we are looking for to get from a certain table. Then there is a from clause. From clause specifies the table that you're trying to get data from. So, and then where clause, that's where you specify the condition. So there's also second part of the statement that has group by, having, and order by. That's what we're going to deal with later. So let's look at select, from, and where first. So this is also a standard format of SQL statement, pretty much what we just talked before, but it gives you an idea how the select statement works. So first, we need to identify the list of tables. In where clause, we need to specify all the conditions, and in group by, we organize those values in certain groups. Having works like a where clause, but only on certain attributes. And once we are done with all those manipulations, once we have our data set, now we can order this data set. And the way we do it, we order it by certain rows or criterias. And as a result, we have a final result down here. Right, so here's an example of of select statement. Here we select asterisk from customer table. So what asterisk means? It means that we are selecting all the columns from customer table. So if you type select asterisk, it's going to bring you the entire set of customer tables. So select from, it's when you use asterisk, means all the columns. you can have different um, aggregate functions as part of your select statement. It can be mass functions, min, max, count, sum, round, and so forth. Can be string function, can be lower, upper, substring, coalesce, stuff like this. Um, you can also use date functions. So for example, when you need to use the next day, that's gonna calculate next day in sequence. So for example, if today is 10th, if you use next day, it's going to bring you 11th and so forth. So there's also some analytical functions that examples are top, limit, bottom. We're not going to spend a lot of time on those, just put it there so you guys know those exist. Okay, so as we remember, select statement starts from select, and then we need to give it a from. But as part of select statement, you can also have all of those math expressions. So here's an example of how to use aggregate functions. So aggregate function works on the entire data set. So here's an example of count function. So what count function does? Count function is going to bring you the number of records from a table. So if you count asterisks, you can select, it's going to bring you the number, a total number of records from trucks table. So here's that. The count only works on a certain when you write it a certain way. So for example, if you execute select name and count asterisks from tracks where album ID is equal to 3, it's going to throw error because name is since you're counting number of records, name is relevant. So it's very unclear what name do you want to see. Do you want to see the name of the first record, or do you want to see the name of the second or the last record? So that is why this type of statement is incorrect. Right. So, and then for the example, we're trying to count how many tracks album with ID3 has, and this is the wrong way of doing it. Right. So there's like operator. So what like operator does, it compares string using wildcards. So when we're talking about a like operator, you can pretty much compare anything you want to in a string. And in this case, if you're using like operator, a percent sign represents many characters, and underscore represents one character. So an example here, when we're trying to select all the trucks that has word "u" in their names, we execute a statement. Select asterisks from trucks where name like "u." So that means that all "u" will be included, regardless where the certain name starts from "u", has "u" in the middle or at the end. All the records will be included. So that is a like operator in very close. Okay, so that's how it's used. And again, like a percent sign represents many characters, and the underscore represents just one. Um, we also use Boolean operators in very close. We use Boolean operators when we need to use multiple conditions. So in this case, and there's three different types of Boolean operators: and, or, and not. And for those of you who took Python, you guys are probably a little more familiar with those. So those are used in very close. When it comes to Boolean operators, there is a certain order on how they're executed. So, for example, in this case, our goal is to find all the product descriptions that looks like desks or tables, and the standard price is greater than 300. So anything that has that end at work desk and work table will be part and has product price greater than 300 is going to be returned from this query. Okay, but when it comes to logical operators, the very important thing is to understand the default order of those. So the default order of operation is always else as follows. First, we execute not, then we execute and then we execute or. So for this query, first, we're going to execute and, right? So if you can see that we have and between product description like table and product standard price is greater than 300. So this and operator is going to be executed first. And then we're gonna execute or operator. So first, we're gonna take all the product descriptions like table. And we are going to add standard price of 300, right? So once we're gonna do that, we're gonna add all desks to the data set that contains tables and products with price greater than 300. And as a result, we have a collection of all desks and tables that are more expensive than 300. So that would be the result set. Again, when it comes to default order of operation, very important to understand how they work. So first we execute not, then and then or. Right? Now, there is a way to override the default order of operations, and the way you do it, you put a parenthesis around. So, for example, in this case, we are executing exactly the same query. However, the only thing that changes, we put parentheses around product description like desks or tables. So in this case, we execute anything that is in the parentheses first. So in this case, we're gonna get a list of all the desks and all the tables. And in addition to that, we are also going to add all the products whose price is greater than 300. So regardless of their name. So the product description for those that are greater than 300 can be chair, can be lamp, can be anything you want. But we will also add all those data records that have a price greater than 300 to the result set. Okay. All right, so default order of operations, the way we override default order of operation, we put parentheses around it, okay? So now, there's also is null operator. So is null operator is used in very close when you need to find values that are null. So there is two ways of doing it. One way is to type is null, and another way you can just write company is equal to null. Both of those will bring you the same exact result. Okay, so is null allows to find data that has a null values. In this case, if you look at the result set, you can see all the companies that are equal to null. So there's is null statement. Very good operator is between. Between operator allows operates on numbers, and it allows us to find all the records that sits in between two values. So in this case, we are trying to select all the invoice items with price between 45 cents and $1.45, and we just use between operator on unit price, and it brings us all the unit prices that sits between those two values. Between operator works only works on numbers and dates. It doesn't work on character strings. So you can say, bring me all the customers between John and Eric. So it's not gonna work. All right. So important. Distinct values. So distinct keyword allows us to select all non-repeating values for a certain column. So for example, we can, when we don't use distinct, we're going to return all zeros. But when we use distinct, we are only going to select all unique values. So with distinct, we're still going to have null. So null is going to be part of the distinct values. So for example, the difference between using distinct keyword and not using distinct keyword is here. So if we select everything from invoice items without distinct, we're going to have a lot of results, and you can see it on the right. When we use distinct value, that is going to bring us the list of unique values for the invoice ID from the invoice items. And as you can see, total is much larger when we use non-distinct values versus distinct. So in and not in. Those two operators work on the list of strings. They can also work with numbers, but usually people use in and not in when they need to find the values that belong to a certain list. So, for example, in the first query on the left, we're trying to find all the list of all the genre IDs and names. From genres where the name lives in rock or jazz. So we need to find all of those names and genres. Um, Not in is an opposite of in. So we're trying to find all the genres where name is not rock or jazz. So it's gonna, as a result set, it's gonna bring us everything that is not rock and jazz. So again, in not in gives you a list of values that either in the list or not in the list. So for example, in your homework, you will need to bring me the list of, I think, astronauts from certain countries. So that would be a good use of in keyword. So that concludes first part of the statement. Now let's talk about a second part of the select statement. So we're going to talk about order by, group by, and having. So let's start from order by. Order by allows us to sort the results. So you can sort them by descending and ascending. By default, we sort ascending. So if you don't specify how you're going to sort them. It's database is going to return you the sorted list. By default is going to be ascending sorted list. So here's a format of the statement. So you select, you give it a column list from table list, where condition, and then order by. You can use ascending or descending. On the example on the right, we sort by last name in without specifying that it's ascending. So database knows that it's ascending by default, and here is gonna sort us all the last names by alphabet. And when we talk about descending, it's gonna also sort the results set, but it's gonna sort them starting from Z to A, right? Self-explaining. So order by clause used to sort the results. Group by clause. Group by clause is a little complicated. So we use group by when we need to categorize results by the certain aggregate functions. So we talked about aggregate functions. Those can be mean, max, average, count, stuff like this. So when we use an aggregate function, but we also want to add some data to that, that's where group by comes very handy. So in this example, we're trying to select all the invoices by the state and display bill and city for those invoices. So we use invoice count, invoice, and we can give it an ls as, and that's where we use count asterisk and as, and we use we're gonna have a specific name for this column called invoice count by state. And we also have a bill and city here. That is something that we're going to going to display. Very important. Every time we use anything in addition to count in a select statement, we need to add this anything to group by expression. So um, you can see that we display bill and city, and then we give it a number of records by that. So with group by expression, we can use vector aggregate. We can use vector aggregate, and that's an example of vector aggregate. And we also can use scalar aggregate. So scalar aggregate returns us a single value from aggregate functions. So, and vector, when it comes to, this is an example of vector aggregate. So when we talk about vector aggregate, we can return multiple values from a SQL query. And in the case of vector aggregate, we need to use group by expressions. So again, every time we need to add more categories to the result set, to the select statement, in addition to aggregate function, we need to use group by expression. And we use this group by expression for a specific fit. Right. And the last but not least is a having clause. So having clause allows us to further qualify results that are grouped by certain criteria. So in this example, group having clause works very similar as the where clause, but it works on grouped categories. So in this case, we're trying to get number of invoices per state, but we also need to only display those states that have, or states or cities that have more than 10 invoices. So again, we can't use where clause because it's already a group by result. So in this case, we are just use having clause to put a condition. So again, having is a way to further identify the result set after the group by expression is used. And that's all I got for SQL lectures. So SQL is more about practicing, less about lecturing. So if you guys have any questions, let me know. But other than that, that's it for today. And the second part of today's lecture is going to be practice how to actually write SQL queries.